Okay, this is section 10.3. We're right back to algebra's favorite game, which of course is solve for x. Okay, so we're solving for x. However, we have a new weapon. We have our weapon of I, and I equals the square root of -1. We also have I squared, which is -1. We have I cubed, which is equal to negative radical -1, or a faster way to call it is -I. And then we have I to the fourth, which equals 1. And again, this is a cyclic pattern that keeps happening. The big thing is the definition here of I, which is I is equal to the radical of -1. So we're going to use this idea to help us solve problems. Also with us is our trusty friend, the quadratic formula. Not to be confused with a quadratic equation, but the quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, we're going to use this a lot also. This is something we should be familiar with. If we need to do some review, that's fine. Just let me know. So we're going to be operating this. So let's do it. Let's take a look at our example here of x squared minus 2x equals -2. The first thing is we can't solve for anything unless it equals 0. So we need to set this to x squared minus 2x plus 2 equals 0. Now we're in a position where we can use the quadratic formula. So we're going to say that x equals, and what we'll remember is that this is a, b, and c. Okay, so -b, so +2 plus or minus the square root of -2 squared minus 4 times 1 times 2. All over 2 times 1. Okay, so there's our setup. Now it's all just plug and chug. So now we're going x equals 2 plus or minus the square root of 4 minus 8, which over 2. We can continue to wrap this up. Now we have x equals 2 plus or minus the square root of -4 all over 2. Now before, it used to be once we got here, we were done because we have a negative in the radical. And that used to not be okay, but now we have powers to work with this. So we can actually say this is equal to 2 plus or minus 2i all over 2. This 2 on the bottom gets, well, here, I'll just rewrite it for you. This is 2 over 2 plus or minus 2i over 2, which if we wrap this up, this is really 1 plus or minus I. And this would be our answer. Okay? We have two answers here. There's 1 plus I and 1 minus I. Okay? Notice that they are the conjugates also. So 1 plus I and its partner 1 minus I. So what's cool about imaginary numbers is if you find one of the roots, so if I only found, say, 1 plus I, the negative comes for free. So if I told you that 1 plus I is a root of this quadratic, then you could immediately tell me that 1 minus I is also a root. All right, let's do one more. So I have x squared minus 6x plus 10 equals 0. It already equals 0, so I can apply my quadratic formula right away, knowing that this is a, b, and c. The a is actually the one that's hiding out front here. Okay, so I can say x equals 6 plus or minus the square root of -6 squared minus 4 times 1 times 10 all over 2 times 1. Okay, there's my setup of the quadratic formula. Now it's all plug and chug. 6 plus or minus, this is 36 minus 40 all over 2. This gives me x equals 6 plus or minus -4 all over 2. This is now x equals 6 plus or minus 2i all over 2. So this can be rewritten as 6 over 2 plus or minus 2i over 2, which is really just x equals 3 plus or minus 2i, just I. Okay, again. Okay, I got one more little quick formula to show you too. Instead of difference of squares being the only thing we're reserved to, now that we have I to help us out, we have the sum of squares becomes possible. And what this ends up equaling is this can be transformed into x squared minus y squared I squared. Okay? And the reason we can do this is because I squared equals -1. Okay? So this would change this back if we were to try and go the other way. This would be -1, which would turn this into x squared plus y squared. Once you're here, okay, you can break this into difference of squares, which we are familiar with. So this is really yi squared, and this is really x squared. So this will then change into x plus yi times x minus yi. Slide that over, yi. Okay, so it's difference of squares, really, but it starts as sum of squares. We use I to change it to a difference of squares, and then we apply difference of squares. So let's try an example. Of 4x squared plus 9. Okay, these are both perfect squares. So what we'll do is we'll use the sum of squares trick to change this into 4x squared minus 9i squared. Okay, we'll then use our difference of squares. We can say that this is 2x being squared minus 3i being squared. And now we'll use our trick to say that this is 2x plus 3i times 2x minus 3i. Okay, I told you guys difference of squares was going to keep popping up, and here it is once again. Difference of squares is one of those things that makes me feel really warm and fuzzy in math. And again, it pops up again, so kind of just makes my world feel even better. If you have any questions or comments, please let me know, and we'll talk about this tomorrow. Have a good day.